Solve the system of equations using the elimination method. We have two equations here. That makes up a system. A system is when you have two or more equations. These are both linear equations. What we ultimately want is the x value and the y value that solve both of these at the same time. So we're looking for an ordered pair, an x and y value that solve both of them simultaneously. And we're going to be using the elimination method. The first step in the elimination method is to make sure that the equations are lined up. The x terms are lined up, the y terms are lined up, the equal signs are lined up, and then there'll be a number that lines up on the right-hand side. When you have it lined up, the next thing you want to do is you want to build the coefficients of the x terms up to a common multiple. You essentially want to find the least common multiple of 3 and 4, which would be the lowest number that 3 and 4 both go into, which is going to be 12. Or you could do the y values. 7 and 6 both go into 42. But let's work with the x's. Only pick one terms to work with. We're going to work with the x terms here. We're going to build these up to make them 12s. Now what we're going to do is we're going to make opposites as well. All right, so to turn this into a 12, I need to multiply by 4. So I'm going to multiply the first equation by 4. And you want to multiply both sides of the equation by 4. On the left, it's going to distribute. All right, so I'm going to write the new system right here. So 4 times 3 gives you 12. So this will be 12x. 4 times 7 gives you 28. This is going to be a 28y. And then on the right-hand side, 47 times 4 is 188. There you go. I changed the first equation by multiplying both sides by 4. Now what I'm going to do is I'm going to make this a 12, but I want to make it a negative 12. I want to make opposites. So I'm going to multiply by negative 3 on both sides of the second equation. And again, I'm going to distribute on the left side. So this is going to become a negative 12x. That's a negative 3 and a negative 6 multiplied to give a positive 18y. And on the right hand side, a negative 14 times a negative 3 is a positive 42. All right, there we go. We made opposites on the coefficients on the x terms. Now what you can do is add the equations together. I'm going to draw a big long line and add them together. 12x minus 12x, they're gone. They're eliminated. That's why we made them opposites, so that we can eliminate them. And then 28y plus 18y gives you 46y. And 188 plus 42 gives you 230. And look, now I can solve for y by dividing both sides by 46. And this will give you a y value of 5. There we go, we found the y value of the solution, but we also need the x value. So this 5, when you plug it into the equations, it's going to work, but I need the x value as well. So we can find the x value simply by taking one of the equations and plugging in the y value and then solving for x. So let's just take this top equation here. Got 3x plus 7y equals 47. I'm going to plug in 5 for y. And that will give me a way to solve for x. 7 times 5 is 35. Now you can subtract 35 on both sides. You'll end up with a 3x equals 12. 47 minus 35 will give you 12. And now to get rid of the multiply by 3, you're going to divide both sides by 3. And we get a 4. And there you go. The solution is going to be x equals 4 and y equals 5. You can write it also as an ordered pair. If you write the solution as an ordered pair, make sure you write the x in the first spot and the y in the second spot. There you go.